Now that we've got the overview of streams internals out of the way, let's start diving into how parallel streams is implemented internally. And we'll begin here with kind of an overview, high level, talking about the internals that parallel streams have. And again, you can find a great article by Brian Getz here at this link where he walks through this stuff in great detail. So the first thing to remember here is what can change and what can't change in a Java stream. So there's some things you can affect and some things you can't. So why does this even matter? Well, it turns out it's very simple to change a stream from a sequential stream to a parallel stream. That's very straightforward. All it requires is changing the factory method that's used to create the stream. But that can be deceptively simple. Why is that? Well, it may turn out that you actually slow things down because if you don't understand how the stream works internally, you may think it's just a magic pill that you take to turn something into parallel and everything will get faster, but that isn't always the case. And when you understand how things work internally, it'll make more sense as to why switching something to be parallel versus sequential may in fact be a bad idea. So why it's important is because if performance matters, and why would you bother using parallel streams? If performance wasn't important to you, it's important to know how things work internally so you make the right choices. So to get us on the same page, recall there are three phases of a Java stream, and particularly a Java parallel stream. The first phase is the split phase, and that's what's done with whatever factory method you use, which under the hood will use a splitterator to partition the data source up into multiple chunks. So we have a splitterator for all the built-in collections that are in the Java collections framework, which splits things up typically into atomic-sized units of size 1, although you could control that. The second phase is the apply phase, and that's where these chunks that were created in the split phase are then going to be processed in the common fork join pool. And we'll spend a little bit of time at some point in the course talking about the common fork join pool because it's very interesting and useful to have an understanding about how it works. And then the third and final phase will join those subresults into a single result. And that uses a terminal operation like reduce or collect or some of the other ones we've discussed. And when things run in parallel, there's a lot more interesting opportunities for choices and for optimizations. You can have concurrent collectors, you can have non-concurrent collectors, which don't really matter if you have a sequential stream, but when you have a parallel stream, it can make a difference. And we'll take a look at some point about performance trade-offs between those different collector-based approaches for the combined phase. And it's really important to know which phases you can control and which ones you can't. So you can, in large measure, control the split phase because you can define splitterators. You can, in large sense, control the combined phase because you can define the terminal operators. You can write your own collectors and so on, or take ones that are out of the box. The apply phase is a little different. There's not a lot you can do to the apply phase. A lot of that stuff is done for you with very little control on your part, although there are a few things you can control just a little bit based on some ways in which you give the common fork join pool some ways of either expanding or contracting itself automatically. And we'll talk about that later if we have time as well. So just be aware you can't control everything, but you can control some things. And so when performance really matters, you might want to think more carefully about what you can control and then apply the various techniques we'll talk about in order to control stuff effectively. So that's the end of the overview of parallel streams internals. Now we're going to dive deeper into each of those different phases and see what you can control and what you can't and how you can control them.